Okay, so in case we want to convert any number into a binary number, take for instance, you have this number 1 0 0 0 0 1. So this is a binary number because in binaries we only have 0 or 1, meaning on is 1, off is 0. So now imagine someone gives you this number to say, can you convert it to the actual figure? The steps are simple. Step 1, what we are just going to do is we are going to spread these numbers that we are given. We are going to write it down. So there is this 1, there is a 0, there is a 0, there is a 0. We have actually 4 zeros and a 1 in the front, so we have spread it. Then since binary, we are only dealing either it can only be 1 or 2, so we call it binary because of 2. So it's base 2. So it's base 2. So we are going to put a small 2 on top, a 2 on top, a small 2 on top, small 2 on top, small 2 on top, small 2 on top. Okay, so we go to step 3. So in step 1, we indicated we spread the number up. We had put 2's on top. Now on those 2's that we had put on top, what we are just going to do is to multiply it to the power starting from power 0, 1, 2. So all we are going to do, let me rewrite what we did in step 1. So step 1, we had spread this 1 with 4 zeros and it gave us this, and we had put this 2, 2, 2, 2, 2, 2. So in step 2, what we are going to do is to multiply it with numbers. So this is position 0, this is position 1, this is position 2, this is 3, this is 4, this is 5. So what that means, we can go to step 4 now. So step 4, we are just going to multiply 2 to the power 0, it's C, 1. So we will do we have this number, let's write it down first again with 4 zeros. Okay, so we are multiplying this to the power, so 2 to the power 0, 2 to the power 0, it's 1. Okay, 2 to the power 1, it's 2. 2 to the power 2, it's 4. 2 to the power 3, it's 8. 2 to the power 4, 16. 2 to the power 5, 32. So this gives us something like this. So when we were saying 2 to the power, it's more like we are 2 to the power 1, 2 to the power 1, that's 2 itself. 2 to the power 0, it's like 2 to the power 0. It's basically going to give us 1. It's more like a multiplication of the 2's. So 2 to the power 3 is like 2 times 2 times 2, kind of. So 2 times 2 is 4 times 2, it's 8. So 2 to the power 4, it's like 2 times 2 times 2, which gives us 16. And the other one gives us 32. So we come to this stage now. So this is where it's actually very simple. So once we are at this point, all we are just going to do is to be multiplying. So we are going to be multiplying only at a point where there is a 1, because 1, it means this is just telling us that it should be on, the value should show. Where we are seeing 0 is showing us the value should not show. So here they are telling us there is no value to show, we can do plus. Here they are telling us there is no value to show, we can do plus. Here they are telling us there is no value to show in this line, so we can put 0 plus. Here they are telling us there is no value to multiply, 0 plus. Here they are telling us, okay, since it's 1 here and we have 32, so we are going to indicate the 32 here. The first one we left, there is 1, so it's actually the 1, we are going to drop it down. So it's 1 here. So when we add this sum, it's going to give us 32 plus 1, it's actually 33. That's how we convert binary numbers. So we can be given a number, then we are going to convert it. So we have the following steps. The first one is the binary figure they have given us. Now they want us to say, what is this binary figure? So from the binary figure, the next thing is we're just going to spread it. Then we put a 2, 2, 2, 2, 2 on top. So once we put the 2, 2, 2, 2 on top, we're just coming to go down to the step 3. Step 3, we are all going to multiply it, just the counting numbers. So those 2's we are putting on top, this one will be 2 to the power 2 to the power 0. This is 2 to the power 1. We'll just count 0, 1, 2, 3, 4, 5. Once we put the powers, we'll multiply this now to the powers. So when you get the answer for this, we put 1 here. 2 to the power 0, it's 1. 2 to the power 1, it's 2. 2 to the power what? It's 2 to the power this is this. 2 to the power this is this. 2 to the power this is this. 2 to the power 2 this is this. So once we get these values, the answers that we got here, these are the ones now we are coming to show. So in other words, this is just the position. When we have this number here, the 1000, is just a position to show that the actual base multiplication you find on each be able to carry it on. On this it's off, so the value on this should not be indicated. So just as simple as this. The same way you can get to do something simple. They can give us a number. Let's say they give us a number 19, to say write this 19 into a binary figure. So all we are going to do is simple. We are just going to do this. If they tell us write 19, we know we are going to put 2's. So 2, 2, 2, 2, 2. If we want, we can even just put this. We're just writing something. To the power 0, to the power 1, to the power 2, to the power 3, to the power 4. So we know 2 to the power 0, it's 1. 2 to the power 2, it's actually 2. 2 to the power 4, 2, it's 4. 2 to the power 3, it's 3. It's 8. 2 to the power 4, it's 16. Our number they're interested in is 19. So how can we do 19? We can turn on the light for this. We can turn on for 16. Now which number can we add to 16 to make us 19? So where we have 16, the only number we need is to 19. The number that we need to add to it's actually 3. So how can we have 3? We can turn on the light for 2. So we have 16 here. We can turn on the light for 2. We can also turn on for 1. So we can also turn on this. So in other words, these are the figures. So we have 1, 1, but this 4, it's 0. Here, it's 0. This position, it's 1. So actually getting this number 10011 is actually giving us the number 19. So this is converting between this actual value number, we are converting it to a binary figure. So this binary figure gives us this. If we want to do a short one to take us back to 19, we are going to do the same we did. So it's 1 0 0 1 1. We said we are going to put a small 2 on top. So when you put a 2 on top, we're going to multiply them to 0 0 0. So this is 0 1 2 3 4. Then we are going to, we said we can go to step 2. We write this figure. So 2 to the power 0, it's 1. This is 2. 2 to the power 1 is 2. 2 to the power 4, it's 4. 2 to the power 3, it's 8. 2 to the power 4, it's 16. So we have just been told here to say this figure are positions. Whenever we're given a binary figure or binary number, they're just positions that should show. So in other words, when we look at this figure here where we are on this step, they are telling us this figure should show. So here there is 1 plus 1 to the power 2. So here it's 1, so the 2 should show here, meaning here 1 is there, so we should show the 2. Should the 4 here show? No, it can't show, it's 0. Should the 8 here show? No, it's not on, it's 0. Should the 16 here show? Yes, it's 1. So we have our 16 here. So when we add 16 plus 2 plus 1, it's actually 19. So this can take us back to 19, or we can use the other method to take ourselves back to the figure. So that is how we do the interchange or swapping of those numbers between the decimal and the binary. Thank you very much.